Well, good evening. Whoops. 7:30. My name is Howard Dooley. I'm substituting for T. Jefferson Murphy, our esteemed president, who has taken a break from the heavy burdens of office and has retreated to Hilton Head Island to recover from this year in his presidency, and we'll be back in May. Well, it's a pleasure to welcome you, and this is the largest group we've had as we gradually recover from a year like no other that we've had, at least not in our memory. This is the 92nd year of the Kalamazoo Torch Club, founded in 1929, and I don't think they've had anything like this. So thank you all for attending. As is our custom, I'd like to welcome all of you as members and, of course, then guests. So I'd like to ask you to introduce, if you have a guest at your table. I'll go right to left. So over here on the right.
Thanks, Andy. My guest tonight is my wonderful husband, Jim.
Welcome.
So I have two guests tonight. Dr. Atkins is a professor at Western, civil engineer. And here is my grandson, Brandon. He's a student in K College. He's a third-year student. He likes to be a dentist.
Welcome all. And welcome back old members who I have not seen thus far this year. So our numbers should grow. If you've been away, we will have a meeting, of course, in May. And then we will go into the summer for a couple of meetings and then resume our regular schedule in September. If any of you are eager to present a paper, a talk next year, please email me. I have collected over the last couple meetings some wonderful proposals. So I have 7 out of 9 slots. So I need 1 or 2 proposals. So if you have some ideas you'd like to share with us, let me know. So thank you for that. And I think now we'll go to our program. And Andy Lowe is our brilliant electronic master of these ceremonies. And I think we are now going live on the internet. So tonight our speaker is Dr. Michael Khaghany. Dr. Khaghany is a renowned cardiac and thoracic physician who has practiced in Kalamazoo for a little more than the last 50 years and has saved the lives of, I think, countless people, including our current president, with his surgical skills. Last year, you may recall, before things shut down, I still vividly recall a dazzling presentation here by Dr. Khaghany on the human heart, its medical issues and treatments. I clicked away. I think I must have taken something like 30 pictures with my cell phone of the presentation. Recently retired, Dr. Khaghany has continued to expand his intellectual horizons by taking, by his count, a score or more of courses, in person and online, from Western Michigan University, the Massachusetts Institute of Technology, and Columbia University. His curiosity has led him to courses in, and these are quite a few, in biology, mathematics, at least 3 courses in modern physics, and at least 3 courses in astronomy and astrophysics. So his presentation tonight, when I first saw the list of speeches, was on the universe, the ultimate torch topic, everything. But he's narrowed it down to focus to the amazing science of astronomy. So welcome, Dr. Khaghany.
Thank you, thank you. Thank you very much. Well, hello everybody. I have this one. So I chose this subject because I had always interest in the astronomy subject. From the day I was very young, the time I was sleeping on the roof of a house in Iran, looking at the sky. My father was very interested. He was a lawyer. He was interested to show me the constellation. I remember many of those constellations from my father. And I kept the interest when I was in medical school. I studied mathematics. I got my master's degree while I was studying medicine. At the same time, when I came here, when I retired, I took many courses in mathematics, maybe 10, 12 courses in different areas. Astronomy, Western Michigan has a very good department. I've taken 3 courses, Astronomy 1, Astronomy 2, and Astrophysics. I studied new physics or modern physics, which is basically quantum physics and Einstein relativity, nuclear physics. They're all the realm of modern physics, all interconnected with the astronomy. I took 5, 6 courses in biology. Recently, I took a course from Columbia on virology and a course from Stanford in immunology. It is interesting to just expand your horizon. And I like this astronomy. Please excuse me if I sort of mix the slides here. These are the part that shocked me the most. I'm going to talk about that area because this is very vast course. I mean, you can't just summarize it in 45 minutes to an hour. So I chose few areas which I will expand on it. And at the end, if you have any question, I will discuss your questions. Let's go for it. So what surprised me was this guy. Aristarchus was, as you see from the name, he's one of those Greek philosopher and Greek physicist, if I call it physics then, astronomist. He suggested that the Earth is at the center of the universe. I mean, this is shocking. I mean, the sun is at the center of the universe. Because everybody else is saying, no, we are on the planet Earth, we are not moving. So it doesn't make sense that anything else should be at the center, that the whole universe is created for us, we human. And this fellow was the one that he said, no, sun is the center of the universe, and Earth goes around the sun. Now, this is very revolutionary then. This is 200 BC. But because they couldn't measure, they didn't have a parallax. The parallax, they had it, but they couldn't have very concise measurement of the motion of the stars. They could not prove that point. He couldn't prove his point. So they followed what the Aristotle has said. Aristotle, 200 before him, said no. He vigorously fought for the idea of the geocentric, that's Earth is at center. And this is what the Catholic Church or the Christian philosophy accepted, which, as we know, went all the way to the time of Galileo. And still there are some people that don't believe that the sun is at the center. But we'll come to that. But I was very impressed with this guy, Aristarchus. Ptolemy is the one that you hear from, the Ptolemy. Ptolemy is the same Aristotle actually was before him. He designed the motion of the planetary system, and this is basically what he said. He said that the, see if this works. He said that here it is, Earth is at the center, everything else is going around. The Earth is a sort of a spheric shape. This idea came from Pythagoras, 500 BC. And this is amazing too. This mathematician, Pythagoras, because of the eclipse, when he saw the picture of the sun on the moon is curved, he then said that Earth has to be has to have a circular pattern, a spheric shape. This is 500 BC. This is from Pythagoras. And then this is a full circle, very clean circle. This was suggested by Pluto. Pluto said the universe is absolutely perfect. So everything has to be circle, because nothing better than circle. So this idea lasted for a long time and caused a lot of problem, as you will see. And then as they couldn't explain what happens with the Mars, because Mars at times comes this way and then goes that way, comes this way and goes that way. They could not explain this back and forth retrograde motion of the Mars. So this guy came, this is another philosopher from Greek, he came with this kind of epicircle. He said the circle over the circle. If you look at the chart that Ptolemy put out, Ptolemy was in Alexandria. The chart he put out is so amazing. There are at least 50, 60 circles into each other to explain this complex motion of planetary system. So we know that is not, today of course we know is not right, because as a scientist when you look at it, the science is about simplicity. If it's not simple, something is wrong about it. And this is what actually the philosopher in 13th century British philosopher Occam, some of you have heard about him, Occam razor principle. He says if you have two different competing theory, the one which is the simplest is the right one. And I think that makes a lot of sense. I've seen this in mathematics many times. There are different solutions to a problem, and some of them, one of them is the most beautiful one. The most beautiful one is the simple one. It's the one with 2-3 lines you can reach from the statement to the conclusion, from the promise to the conclusion. So from premise. So anyway, so this was then the idea of Ptolemy about our planetary system, that Earth is at the center of everything and everything is around it. So before him, I mean, you know this guy. This guy is Nicholas Copernicus. Before Copernicus was somebody else that said, forget about this business of Earth. Sun is at the center. But again was rejected. This fellow, who was very religious man, he was from Poland, but he was a mathematician, he was astronomer. He could not publish his information because he knew if he do that, the Catholic Church, the Vatican, is going to come after him. So he decided to publish the book right the day he died. So the book came out when he was dying. Exactly in 1543, the book came out. As you know, this is the time that also about 10, 15 years prior to this, there was a movement in Germany, the religious movement against Catholicism, because they were trying to get more money to build Vatican, the new basilica. So the whole movement of Protestant started in Germany. It was very much coinciding with this stuff. So he was very scared to come up publicly. So when he published his book about the revolution of the planets around the sun, it was the day that he died. That's exactly the same day. So he claimed the sun is the center, but he couldn't escape the Ptolemy, a statement by the Greek philosophers that the circle is the most perfect circulation of the planets. So he still chose to have circle in his model. And this was his problem. This, you will see, this caused a lot of problem because I still could not explain why the Mars going back and forth. And when the people saw that his model of the planetary motion does not explain what was wrong with Ptolemy, they said, forget it. I mean, why we change when it's not able to explain to us where the location of the planets are going to be, when eclipse is going to take place. So his idea, although was a great movement, heliocentric motion, but it didn't go too far. Because of that very reason, the circular motion. Time came, before him was a guy, which I don't have, I purposely didn't put him on because it would be too much. The Thorsten Brahe was a gentleman, was aristocrat, He had a lot of money, and he wanted to do something about this Ptolemaic model, which was not working. Because they were supposed to have the conjunction of Mars and Jupiter, but when they said this day you'll see them all in the sky along the same line, it didn't work out. 2-3 days passed before that conjunction took place. So he swore to himself that I'm going to go after this, I want to fix this. So he worked on this one, and he was promoted by the king of Denmark to develop a planetary system. So he needed a place to study this. He got 2 islands, they gave it to him, and he developed a very nice, nice system for studying the planet. But of course, it was just visual because they didn't have telescope. But he had a beautiful setup about to exactly find out where the lineup is. So it is a circular graded device, and he recorded the motion and the location of every planet that you could see for good 30-40 years. But he still could not come up with a model to explain this. Just about before he dies, this guy is a German guy, Kepler. He was a great mathematician, especially he was a good geometrist. He knew Euclidean geometry, especially a spatial geometry, the three-dimensional. So he hired him, and he was very smart. He came up with some ideas. Unfortunately, 2 years later, he dies. I'm talking about the Brahe. Tycho Brahe dies, and he took over, which was good because he now has access to this all information. 34 years pile of information, location very precise. Every location, every night, you know where the Mars is, where Venus is, where every planet they could see. They recorded very nicely within 1 arc minutes, which is very sensitive. Arc minutes, as you know, the circle is 360 degrees, and every degree divided by 60 would be a minute. And he was able to, within 1 arc minute, to locate every of this planet that they could see. So he struggled. Kepler struggled. Worked very hard. But he couldn't still explain because he was still stuck with the circular motion being the perfect motion. At some point he said, well, maybe 2 degrees is not too bad. Maybe I accept this model and accept 2 degrees as a sort of error. But then he woke up next day, he said, no, this is not science. I have to be perfect, I have to be precise. So he worked and finally found the secret. The secret was that these orbits are not circular. This orbit has to be elliptical orbits. That's the only way you can solve the problem. You cannot solve the problem of planetary system short of using elliptical orbit. The ellipsis has 2 focuses, one on this side, one on this side. Sun is located in one of these foci, and the other one is empty, and the planet moves around it. With this, he was able to come up with three laws, which was evolutionary laws. He himself was not really, before that, he has published many things on astrology, on casting horoscope, and so really didn't have a good reputation before that. But after he published these 3 laws, which I'm going to explain to you, he became extremely famous, and we all know that what he did was magical. I mean, short of magic, I don't know any other word. So the first law, he published this law in 1609. He published the elliptical orbits as his first law. The second law, which is more magical, this magic is here. As the planet moves, in the same time, it sweeps the same space, the same surface area. In other words, this triangle has the same surface area as this one, as long as from this one to this one took the same as this one to this one. Within a month, let's say, if you move on this orbit, the amount that the circle is made between the sun and this planet, that circle, that's the triangle, is the surface of this is equal to this one. So the area of sweeping is equal. This is very revolutionary idea. That's why when the planet gets close to the sun, it goes much faster, because the triangle, now you have a shorter height. You have to have a bigger base. So in the winter, when the planet Earth gets farthest from the sun, I mean, many people thought that winter must be the closest to the sun. But amazingly, if this is Earth, this would be here, would be summer. I mean, would be winter. No, summer, I'm sorry. Summer, and this is winter. So the area that you sweep are equal. And with this, you can then measure the velocity of the orbits very quickly, because at any point you can measure how much distance they have, so you can measure the velocity. You can use other stuff, which I'm not going to go into it, they call angular momentum. But this was the second law he published again in 1609. So two law was published in 1609, and it took him about 10 years to publish the third law. Where is the third law? Okay, the third law, it says the farther you are from the sun, the slower you're going to orbit. So the orbits, but he precisely claimed what is the relationship. He said if you take the period, let's say for planet Earth is 1 year. If you take the period and period to the power 2, 1 to the power 2 is 1, equals the distance to the power 3, provided the distance is in astronomical unit. This unit means the distance from the sun to the planet Earth is called astronomical unit. If you use this equation, this relationship, you can see that as you go farther from the sun, you're going to slow down. So the Mercury is the fastest. It takes about 90 days to go around the sun. But you go farther, you come to Venus, it takes longer. You go farther planet Earth, you go Mars, you go Jupiter, Saturn. As you go farther away from the center, your period increases. It takes much longer. For example, it takes 248 years for the Neptune to go one time around the sun. This relationship was then more accurately described by Newton, which I'm going to talk about him next probably. No, we're going to talk about Galileo. Galileo came around. This is 1964 to 1642. His major contribution was the telescope. He modified the present telescope, which some Danish guy has designed, but it was only magnification, had a magnification of 3. So Galileo himself, very shortly, within 2-3 weeks, he came up with this new telescope that had a magnification of 20. With that, he was able to see the moon. He was able to identify the mountain on the moon. He was able to see the darkest spot on the sun. He was able to see, more importantly, he was able to see the Venus phases. The Venus has phases like moon. Moon comes in a full moon, half moon, come in a crescent. He proved that the same thing happened with Venus. And the only way this can happen is if Venus is going around the sun. There's no other way. You cannot have the Venus going around the Earth and having those phases. So that was the main reason to reject the idea of Ptolemy that the center of the Earth is occupied by the Earth. The best reason, experimentally by Galileo, was proposed when he showed the Venus has phases. And also another beautiful thing he found were the moons of the Jupiter. Jupiter had many moons, probably about 60, 70 moons. 4 of them are the closest. Those 4 moons, the closest is Io, then is Europa, then is Callista, and then Callista. There are 4 different names. But they are the most inner moons of the Jupiter. And if you look at nighttime, if you have a telescope, I had a telescope when I visited my son in Minnesota. He had this telescope. He recently bought the telescope, and it was a big telescope. And about 9 o'clock, the Jupiter came up in the horizon. And the first thing I saw was these 4 moons right along the line, making a straight line next to Jupiter. was the most beautiful thing I remember in my life. It's exactly the same thing that the Galileo has published. If you see the paper by Galileo, the same 4 moons on one side of the planet Jupiter is magnificent, magnificent. And it tells you that all these planets in the solar system are moving on the same plane. That's very fascinating. In other words, it's not that Earth is here, Venus is here, or this way or that way. All of them are the same plane, are on the same plane. And the motion is all counterclockwise if you go above the solar system. If you somehow, if you have a device to look at the solar system from upper part, from north, you can see all the motion are counterclockwise. And this goes along with the creation of this planetary system, how they created the first time. The only aberration is Venus, which instead of going from east to west as the sun rises from east, goes to west, really is west to east. This is reversed. If you were in the planet Venus, the sun will come from west and goes down on the east. That's the only planet that this is reversed. The rest of them, all of them come from east, go to west. And there is another moon of Pluto, which is no longer is called planet. Now it's called a dwarf planet. The moon Charon, the name is Charon. It was, I think, one of the pioneer 2 or pioneer 3 discovered this moon. This moon will also go reverse. Instead of going counterclockwise, it goes clockwise. So we believe that this moon was captured later on. It was not a part of the solar system to start with. But this is the beauty of this orbital system, that Galileo found that definitely the Earth is not at the center, and furthermore he discovered the law of he found the laws of the inertia and the free fall. As you know, these are the one Newton then later on picked up and wrote his law of mechanics. He was a great physicist and mathematician. As you know, in 1633, he was taken to Vatican to explain his position because Vatican was obviously upset with him. But mainly they were upset with him because a year before he has published something, and they thought he has presented the Pope as a dummy in his argument, which I don't think was intention, but simplifio means simple man. They thought that he was arguing that sun is at the center, and the other guy was arguing the Earth is at the center. There was some problem to do with that. So Galileo was forced to reject his idea about Earth and sun, that the Earth is at the center, not the sun, and he apparently accepted. But it took up until 1992 when John Pope II is finally vindicated Galileo. It took a long, long time. Just think of it. 1633 and even year 1992. So here we come with this great man, Newton. Newton is famous because he came up with the law of mechanics, with the law of motion. The 2 first laws are really from Galileo. The law of inertia definitely is from Galileo, but now it's called the first law of motion of Newton, and second law, of course, is the force is related to the acceleration, directly related to the mass, and the third law of the motion, which has to do with any action has equal but opposite reaction. But the most important of them, I think, is the law of the gravity. This gravitational force that nobody could explain, he came up with this beautiful law that any 2 masses would attract each other. And this attraction has to do with the size of the mass and indirectly related to power 2 of distance. If I increase the distance by factor 2, I reduce the attraction force by factor 4. If I reduce the distance by 3, I reduce it by a factor 9. So this is the law of gravity, which also shocked himself, shocked Newton. Newton could not explain why there should be a gravity between Earth and the sun, or between, let's say today we can say between the Milky Way and the neighboring Andromeda galaxy. Why? How come this force works? This was a puzzle up until Albert Einstein finally solved the problem, which I explained to you what it is. So he invented the calculus, which is a huge, huge jump, because we needed to find a way to explain these motions. We needed instantaneous velocity of any object. We are not stationary. We are, and every piece in the universe is moving. So we need equations. We need a kind of mathematics to explain these motions. And these motions, which has to do with the derivatives and integration and differential equation, all came because of him. And a co-inventor was Leibniz in Germany. Without having any knowledge of each other, Leibniz came up with the same equation that Newton came in England, in Cambridge. He came in England, he came in Germany. Many people accused him that he has stolen from Newton, because once he visited the Royal College of Science in England, when there was a discussion, they thought Leibniz had stolen the idea from him, but it's being pretty much rejected. But anyway, this is a huge discovery, and everything we had, the revolution that happened in the industry in 18th century, 19th century, all has to do with the Newtonian mechanic and the calculus. Without this, it would be impossible that we go to moon. No way. Then he talked about the light. He said light is corpuscle, is not a wave. He thought that light was pieces that are coming from sun to us, making us warm. This idea was rejected by the people who thought that light is wave. And today we believe that light is the combination of wave and corpuscular theory. Both are combined together, because this is based on the quantum physics. There is no way you can explain the phenomena only by motion of the waves, or by corpuscular, which is the quanta, which is the discussion of quantum physics. You have to have both of them together. So here comes this great man, is called Albert Einstein. He caused a revolution in science. He's born in Germany, as you know, and he died in New Jersey in 1955 from ruptured abdominal aneurysm. His great contribution are this special and general theory of relativity. And he proved that the space and time are connected. They are not two separate items. Before, during Newton mechanics and Newton physics, they thought time goes for itself, and the 3 dimension of the space are totally separate. And it's very intuitive to take this idea, why they should be related. But this guy came and said, no, they are related. Space-time are not separate. So he came with a four-dimensional. The 3-dimensional is space, and the 4-dimension is the time. He came up with this equation, which in this equation was contribution of the non-Euclidean geometry. And then he proved that energy and mass are related. They are not separate entities. Before we thought mass, there's a law of conservation of mass, law of conservation of energy. He said, no, they are interconnected. And he proved that. E equal mc2, the most famous equation. You can convert the mass into energy and vice versa. And this was the way that we found out finally what happens in the sun, how sun gets all this energy. Before that, they thought it's a contraction of the sun that causes this energy. They call it Helmholtz contraction. As you contract, the gravitational force turns you energy. But Einstein came and proved that this was related to conversion of part of the matter into energy. And then he predicted existence of the black hole, which was very revolutionary. They thought this crazy idea. And of course, gravitational lens and gravitational wave, which are different subjects. I don't want to touch on those, but I may come across the other one. And then comes here this guy, Hubble. Hubble is an American scientist. He was graduated just in 1917. He was drafted in World War I. He was astrophysicist. When he finished, he came and worked in the Mount Wilson Observatory, which was recently just had this huge telescope, 5-meter diameter telescope, the biggest telescope ever created then. For 30 years, that was the biggest. So he made all observations using that telescope. He proved that we, means Milky Way, are not the only one in this planet. There are others, galaxies. Because a big debate in 1920 in Washington between two great physicists, one from Harvard, one from California, from UCLA probably. The debate was about, is the Milky Way it? That's all it is? Or other galaxies exist? All we saw, if you look at night, everything you see belongs to the Milky Way. The only spot that doesn't belong to Milky Way is a spot which you have to use binocular to see it. And that is Andromeda. They call that nebular spiral. They thought that is just a part of the Milky Way and just a cloud. But this guy from California argued forcefully that this is a different galaxy, and he proved to be right. But the proof came by this guy, Hubble. When Hubble sat behind those telescopes, he saw with his own telescope stars, distinct stars in that patch of cloud that they thought this was a part of. So he proved there are other galaxies, and then he measured the speed, and every night they look at different galaxies and recorded them for a year, for two, and he found out they're running away from each other. The galaxies are not a stable unit. They are moving apart. They're separating, and as they get farther, their speed increases. This is very fascinating. Their speed is not fixed. It's not that you go 30 miles an hour on the highway. You go 30 miles an hour the first hour, 45 miles the next hour, 60 miles the third hour. The farther you go from city of Kalamazoo, the bigger your speed gets, and farther you go. This relationship between the velocity and the distance was something Hubble found and called it the Hubble law. Right here. The Hubble law says that the velocity is related to distance. As distance increases, this increases. This was amazing. And from that, they found out that, okay, if this is the way it is, they're escaping, there must be a beginning then. If these galaxies are escaping from each other, then they must, at some point of time in the past, they must have been together. And going back, just with some computation in mathematics, you can find exactly when the universe was born. Whatever you want to use the term, created or born, whatever came about. That was exactly 13.8 billion years ago, with that equation that Hubble proposed. Now, here's a good example. Imagine that this is a balloon full of air, and this yellow spot on that are the galaxies, different galaxies. As the time goes up, the balloon inflates, the galaxies start to separate from each other. It is not that this galaxy goes into empty space. It's a space-time that expands. This four-dimensional space-time, which is hard to imagine, expands as a result. The galaxies move with it. And you can see before the communication, if you send a signal from here to here, it was a blue, on a blue spectrum. Blue means very high frequency. As the distance increases, this shifts to the red. You can see this with the spectroscopy. You can see the spectrum of the hydrogen moves from this point toward the red part of the spectrum. That means they're moving away from us. If they come toward the blue, they call it blue shifting. That means coming toward us. This was yesterday, this is today. And tomorrow will be much bigger. This is how the universe is. The universe is expanding and expanding ever more and more with more speed. And here is the possibility of expansion. This was then, this was before Hubble. They thought, okay, this was a Big Bang, okay, the universe expanded. At some time, the gravitational force pulled them back together and came to big crunch. This was the belief for many, many years. Expansion, come back together, crunch, then again another Big Bang. So they thought the universe keep on doing this. But this theory is rejected, and not only is rejected, this is the latest. The latest put out by observing the distant galaxies, and it shows not only the universe is expanding, but the rate of expansion is increasing It is not a straight line. If it was a straight line, that means the velocity is fixed, because that's how it is in mathematics. This is parabolic. It just goes like this. That means the speed is increasing. The speed is increasing quite a bit. So this is the story. This is the state of the universe today. The universe is expanding at a bigger rate. At some point, it may go close to the speed of light. And at that time, I will talk in the next part of the discussion what happened to energy, and if we lose the energy, we turn into a cold, cold universe. Nothing. Okay, so this is another interesting part which shocked me. Really, this was. What you see with the telescope is only 0.5% of what exists in this universe. It's amazing. This telescope, you see all these things, galaxies. You think this is only 0.5%? What about those 99.5%? Here it is. 4.5% of that is energy, which is, you don't see it with telescope, but you know it's there because sun is hot. And the other 95% is shared between the dark matter and dark energy. So what is dark matter? Dark matter means we really don't know much about it. We know that it has attraction force like gravity, but doesn't have any other signals. Does not give you, let's say, electric signals. Doesn't have any electromagnetic activity. So how do we know it's there? Because we know by gravity. Increases the gravity as you get close to it. So 25% of the universe is this, 23%. And the other one is energy. That energy, what is that energy? Energy was the reason for this. You might ask, what makes this planet, this universe, to keep moving so faster and faster? That is that dark energy. So dark energy causes the galaxies to go farther and farther apart, and dark matter is the reason why these galaxies are held together. Because we will find out that the gravitational force of Newton is not enough. What Newton wrote is not going to explain this. So then observer universe has more than 100 billion galaxies. By the way, this is slide I prepared this about a year ago. Now it's about 300. They claim there are at least 300 billion galaxies, not 100. And every galaxy, like ours, Milky Way, has 100 billion stars. Just think about it. When it was 100 billion galaxy, 100 billion star, you can compute this mathematically. It equals to the sands of the entire shores of the planet Earth. If you go everywhere and take all those sands and count them, put them together, that's the number of stars then. But we know that it's 3 times as much than that. So we discussed about this part already. Now here, I want to pay attention to this one. This is a beautiful one. This was put forward by Carl Sagan. Carl Sagan was a great astronomer, astrophysicist from New York. He said, let me just to explain to you guys what I'm talking about. Let me just take these 14 billion years of creation. I use the word creation loosely, by the way. I'm not a religious person. These 14 billion years that we exist, let's contract that to 1 year. Let's say we are existing only from the inception to now 1 year. So we are, right now, we are on the midnight, December 31st. January 1st, the universe came about, and here we are, December 31st, midnight. Let's see what happens. This is very fascinating if you pay attention to this one. So if you look at it, so our Milky Way, which we live in it, we're part of it, was born in mid-February. The solar system, which we're a part of it, was born in middle of September. December 17, which is about 550 million years ago, the Cambrian explosion took place. The Cambrian explosion means suddenly we see on a layer of deposits lots of fossils. What were they? Suddenly they showed up. Trilobite. So many other creatures which live in water, suddenly they came out. And we think that's because the oxygen of the atmosphere increased, and because the metabolism changed from the anaerobic to aerobic, suddenly this explosion took place. So this is a Cambrian explosion. Happened in December 17. See? 13 days ago. The dinosaur came on December 26th. 250 million years ago, dinosaur showed up on the planet. And then became extinct on the December 30th. 4 days they were on this universe. And the reason it became extinct because we know there's a meteorite 10 miles in diameter hit the planet Earth. And we know exactly where it hit. It hit in Yucatan Valley or Yucatan Peninsula in Mexico. We have found out where exactly it hit. It's a 200 kilometer in diameter, the crater that created. The energy that was released equal to 100 million hydrogen bombs. Imagine 100 million hydrogen bombs. And that destroyed more than 70% of the species. They were gone. We don't know what they were. They just disappeared. And the other 30% lived. But altogether, 99% of the living creatures died. Fortunately, some mammals, like mouse, were similar. They were used to go underground, and they were able to survive. And because of those mammals, we humans are on this planet. Because the evolutionary process took over, and in the span of 65 million years, different creatures came about, and we humanoid showed up about 5 million years ago, and about 70,000, 80,000 years ago, we left African coast, East Africa, come through the Middle East, through Israel, through the Carmel Mountain, that area, separated, once went to Europe, portion came to Asia. The Homo sapien, before that were Neanderthal, then Homo sapien came. Some of them married in Carmel. As a result, 4% of the gene in European ancestry are from Neanderthal. But the story has to do with this dinosaur. Now, why we say this is true? Who can claim that this thing happened? First of all, we found where it hit the planet, but beautiful thing was by the Alvarez, two scientists. Father was the atomic physicist from Caltech, and son was the geologist. They were studying in South Italy. They came across this line, which was black line, and then when dug into it, they found there's no fossil. Before that were tons of fossil, but you go after there's no fossil left. So something happened to dinosaur. What happened to this deposit? That suddenly from here, concentration of fossil is magnificent, but you come to this layer of soot, black stuff, and then above that, there's no fossil, all gone. So they figured out something happened to planet Earth, and that was the entire forest in planet burned from this heat, and the soot came down and deposited all over the planet Earth, because now we have that line everywhere we go, we can find it. And furthermore, this is another reason, the concentration of iridium. Iridium is a metal which is very rare on the planet because it's heavy. At the inception of the development of planet Earth, went down deep. So the only way it can come out is volcano. The main source of iridium, which is used mainly in the car industry for a spark because it's very resistant metal, the only source is the meteorite. There is no other source. So you can measure this concentration of iridium in this layer is 100 times more than other layers. So that means something brought this iridium to the planet, and that was a meteorite that hit the planet Earth. So yes, 65 million years ago, this happened to the planet. Will this happen again? Of course. Of course, there's wandering meteorite all around the meteorite belt between the Mars and Jupiter. Has billions and billions of these pieces. They can escape, and some of them may just find their way on the planet Earth. So dinosaur got vanished, and look what happened here. So to continue with the calendar, 9 p.m. We came on the group, but we means our ancestors. Hominid. Hominid was just walking like this 5 million years ago. 5 million years ago. At 11:58, 2 minutes to midnight, we modern human, Homo sapien, left Africa or came about. And then 11 seconds ago, midnight, the pyramid was built by Egyptian. A second to midnight, America was discovered by Columbus, right? 1492. And the human life is nothing but a blink of an eye. So just think of it. Who are we? We're latecomer in this universe, and we think we are God. Some of us. Okay, this is another eye-opener. When Hubble Telescope, which is outer space telescope, when they repaired this mirror of the telescope, which, as you know, 1990 was launched, they found it's not working well because engineering was not well at the periphery of the telescope. So they had to send a mission, which was a magnificent mission by the NASA. And as you remember, this is 1993. They repaired this. They repaired this mirror, which is a great engineering task. I mean, just think of it. 600 kilometers above the planet Earth, this going with the highest speed, 11 miles a second, you're going to go there and repair it. And they did it. Once they did that, they decided to observe the sky. And here what they did. They observed the sky for 23 days. What I mean by that is not continuous 23 days. Because you have to, with gyroscope, you have to keep on moving this telescope to concentrate on that very spot. That spot they used was the blank spot in the sky, size of a tenth the size of the moon, very small area. They put a telescope, they zoomed on it. With this gyroscope, they kept changing the direction so it stays zoomed. And the total of 23 days, they did this. And then, to their surprise, when they developed this is our computer development. When they developed this, they saw this magical view. Look, there are close to 10,000 galaxies. These are all galaxies. These are not the stars. These are galaxies. These are empty space was supposed to be nothing. Nothing. You looked at it and you found there is 10,000 galaxies. And these ages are not the same. Some are 5 billion years old. Some are close to 10 billion years of age. There are different ages. And you can figure out the ages of this, by the way. There's a way to do it. So here is our neighbor, the beautiful neighbor Andromeda. Andromeda is 2.5 million light years away from us. If you want to have an idea about light years, let me tell you this. When I turn this laser on, if there was a way to go around the planet Earth, which doesn't go because it goes straight. Let's imagine for a moment that there's a law of physics that makes it move around like this. If it happens, it would have gone 8 times around the planet Earth in 1 second. In 1 second. This flashlight would have gone 8 times around the planet because the planet is 40,000 kilometers in circumference. 8 times 40,000 would be 320,000 kilometers a second. That's the speed of light, 300,000 kilometers a second. So imagine this is 2.5 million light years away from us. In other words, the light, if this galaxy goes away tonight, we are not going to find out up until 2.5 billion years from now. Because there's no message coming. This message was sent today. It's going to be this long on the way. The message was sent from the satellite we sent to Saturn. It takes about 80 minutes to get to the planet Earth. And that is a part of the solar system. Just think of this. This is the closest to us. Closest. It's not far away. The closest galaxy to us is this far away from us. This has 200 billions of stars. And it's a spiral galaxy. A spiral, you can see spirals all around. And I show this because our Milky Way is like this. Of course, we can't go outside the Milky Way to see what it looks like, but we can surmise from neighbors and using some mathematical modeling and measuring the speed of the other stars around us, we can figure out what its shape looked like. By the way, that is moving toward us with a speed of 300 miles a second. And one day it will hit the planet Earth. I mean the Milky Way. But we're not going to be here. I'm sure you have seen this, right? This is the Milky Way. This is what you see in a moonless night, in a clean, cloudless sky. Not in Kalamazoo because the light pollution, you will not be able to see it. But you go deep into forests when there's no light. And if you can see up the sky, cloudless, and moon should not be out, would be the first day of the month or the last day of the month, then you will see this Milky Way. This is the Milky Way, and this is the center of the Milky Way. This is where the greatest piece present, which I will talk about that. That is the black hole. That black hole has a mass of 4 million suns. Our sun, very heavy, 4 million of those suns makes this black hole at the center. This is the center, it coincides with constellation Sagittarius. And here is the model of our Milky Way, the spiral galaxy. Again, this is artist's conception. So we have the central bulge, then we have the spiral arms. We are somewhere here. We are on the Sagittarius arm, about 27,000 light years away from the center. And here's another a schematic of our Milky Way. Here is that galaxy center, which is a black hole here. This is the bulge, and this is the solar system here, sun. This distance from here is about 27,000 light years. So we are far away from the center, which is a good thing because there's a lot of radiation going on here. So hopefully it wouldn't affect us because we're too far away from it. So the Milky Way, our home, is 13.6 billion years old, is a spiral galaxy, is 100,000 light years in diameter. If I go from one end to the other end, it takes 100,000 light years, which I talked about what the light year was. And the thickness of that is about 2,000 light years. The thickness, or 1,000 light, 1,000 means up and down. Up and down is about 1,000 light year. This way is 100,000. And then has about 100 to 200 billion stars. The sun, our sun, is this much away from the center, which I talked to you. Supermassive black hole at the center measures 4 million weight of sun. Weight is the wrong word, mass of sun. Weight has to do with gravity. Here I'm going to show you this one. This is our neighbor, the closest star to us, a star, not galaxy. This is a part of the Milky Way. If you're here, this is sun or planet Earth, to here, it takes 4.5 light years to get there. Right now, the four spaceships which NASA has sent since the inceptions, 4 of them have left our planetary system, the solar system. They are going into the space, into the void of space in the Milky Way. They are not aiming to go here, but if we are aimed to go this way, it would take them 100,000 years to get there. And they're going with the speed of 1/10 of the speed of light, which is pretty impressive. It still would take 100,000 light years, 100,000 years to get there. So you can see how far we are. Now, if you go back to the model which I showed you, you reduce the size of the universe by 1 to the 10th billions. So our solar system would be in Washington. Then there would be nothing between us till this star, which is in San Francisco. Think about the US. There's nothing from Washington to California. Everything is void. So it's a very empty space. Not empty in the sense of being empty, because empty doesn't make sense anymore. We know there's some matters, dark matters in that space. But between the living stars, there's a huge space. So our solar system is this many years old, 4 or 6 billion years old. not as being claimed that only 4,000 years old. In some books, they say that. Sun contains, this is another thing that impressed me the most. Sun has 99.9% of the mass of the solar system. So everything else is just 0.1%. Everything else means us, Earth, Moon, all its moons, Jupiter, everything else you know in the solar system put together, they only are 0.1%. Sun is getting brighter. And why is it getting brighter? Because the hydrogen at the center is burned into helium, so the volume is reducing. As the volume reduces, it contracts, and that potential energy of gravitation turns into heat. The temperature goes up. There is more fusion taking place at the center. More hydrogen is burning. The temperature goes up. The sun has become brighter by 30% since the inception, and it will continue to get hotter. This is what's the problem with the planet Earth in the future, because not only we are dealing with this climate warming, we're also dealing with the hotter sun that's attacking us. The days are getting longer, and that has to do with the attraction of the moon. As the moon pulls on this planet Earth, makes the planet to go a bit farther away from the sun. So our distance from the sun increases, and also the revolution around its axis slows down. Our moon continues to run away from us the same way. The moon is also, every year maybe about half an inch. It's getting farther. We know that because we have a laser on the planet moon, which we put a plate, which send the laser, we can measure it, and we can see the distance very accurately. So every year about I think an inch, if I'm not mistaken, the distance increases. So at the beginning, the Earth, the days were only 6 hours. At the beginning of the inception of the planetary system, the planet Earth was revolving every 6 hours around its axis. But now it's 24 hours, right? So our sun is an average star. It's not a big deal. It's average star. It's continuously fusing hydrogen to helium based on this equation of Albert Einstein. This is a beautiful equation which solved the problem of conversion of the mass to energy. And if you ask how much the mass would convert to energy, only 0.7%. If every 100 grams of hydrogen at the center, only 0.7 gram of it turn into energy. The rest is not going to burn. So it's not a complete conversion. It's a partial conversion of the matter. And the hydrogen fusion would last another 5 years, another 5 billion years. So in 5 billion years, we are done. The sun is going to go quiet because its energy is a reserve of hydrogen at the core, because core is where this takes place. The core is at 10% inside the sun. That's where the action takes place. In 5 billion years, that becomes quiet and turn into what is called red giant. It becomes very, very big to the point that will encompass the planet Earth. In other words, at some point you open your eyes, you see the sun is close by, and before you close your eyes, has covered the planet. And everybody, of course, is melted. So in 5 billion years, the planet Earth turned into charcoal, at least the surface would be all burned. Of course, before that, even billion years before that, the temperatures go so high, like 1,000 degrees, nobody can survive. The only hope we have for survival is we escape. And the only place to escape is one of the moons of Saturn, called Titan, or some of the moons in Jupiter, like Europa, which has a lot of water, ocean of water. There is no other hope. Jupiter even is too close. Saturn, by then, the temperature of Saturn would be 80 degrees, which is very pleasant. It's like San Francisco. You can get to it. So the quark, which is left from the sun, is called white dwarf, because the outer shell would explode and goes away. What would be left would be the size of the planet Earth, and is a beautiful thing. It's very hot at the beginning with a 33 to 4,000 degree temperature. As the time goes by, it gets cooler, cooler, and cooler, and turn into a dark dwarf eventually. This is the story of sun. The sun would last 5 billion years. Its life is limited, like the life of any living or non-living creatures. So here is what happened schematically with the sun. This is based on a mathematical modeling, so we know what's going on, because so far, every experiment showed the model is correct. The action takes place at this 10% inside, you call core. This is radiation zone, this is convection zone, and this is where the temperature reaches us about 5,800 degrees. And most of them are in the spectrum that we see. We human, our eyes is evolved so we can see that spectrum. But this spectrum is pretty wide. It is in the ultraviolet, is in the infrared, is in the X-ray. Fortunately, our ozone layer and our atmosphere absorb the X-ray, doesn't get to us. But if it were closer, would be a tremendous amount of X-ray coming from, not from the sun, but from corona, which is around it. Have you seen when the sun eclipse happens? It's a beautiful scene. When you look at it, you see when the center is covered by moon, by the shadow of the moon, then you can see the corona. The corona goes way to here. Brandon, you remember, right? I took him. The temperature of this is close to 1,000,000 degrees. Corona's temperature, and that's where the X-ray comes from. So here is the eventual picture. Now our sun is blasting away its outer shell. This is called planetary nebula. It's a very beautiful color because the ultraviolet light hits it, makes it green. And this is when it becomes the red giant. This is when it will cover the planet Earth and goes beyond, goes to Mars even. It's that big. So let's see what happened to us in the past hour that we were here. If we were talking about planet Earth as being a ship, see what happened to it. We already turn around every hour 1,600 kilometers around the axis. Of course, we're up north, maybe a bit less. This is the equator of the planet Earth. Up higher is less. Orbital rotation is 100,000 kilometers. In other words, 1 hour, the Earth has moved 100,000 kilometers in its orbit. And furthermore, the sun has moved around the center of the galaxy with 800,000 kilometers an hour. So put this all together, I don't want to go through detail, we have moved 1,000,000 kilometers from where we were an hour ago. It's hard to imagine. You're sitting here, we think everything quiet, if nothing is moving. But in reality, everything is moving. So what happened to the stars? The stars are born to die. It's like us, like all biological phenomena, even inert stuff happens to them. So what happened to a star? First of all, the stars are continuously born. Secondly, they are finite life. A star is not forever. Thirdly, the bigger the star, the shorter the life. It's the same thing like fat people have a shorter lifespan. Why is that the bigger star have shorter life? Because they spend a lot of fuel. They are much hotter. And they use this fuel much faster. So they live about 30 million years, 100 million years, instead of 10 billion years like our sun. So, and then most of the matter is recycled. In other words, it doesn't go outside of the galaxy. It will be used over and over again. We, human, are the result of the dust from previous supernova that happened in this vicinity that created all its elements, carbon, oxygen, nitrogen, everything we have, because the universe was only hydrogen and helium. So where all this come from? They all came from supernova, from explosion, which I will touch on that. So we are born from the dust and will become a dust eventually as we die on this planet, as that day that comes that we turn into charcoal and then we go into space. So we become a part of intergalactic dust, which is not a bad idea. Our atoms would become part of somebody else's. So low mass star turn into like our sun. Intermediate turn into neutron star. And big mass turn into black hole. Because the time is short, I'm going to go fast. The white dwarf I told you about, the center of the white dwarf, our sun, is carbon. Carbon turns into diamond. So we're going to have a huge diamond, but there's no use to us because we're all gone. The 1 teaspoonful of that white dwarf, bring it today on this planet, has 10 tons of weight. because the matter is so dense. The space between atoms is gone. It's close together. So then become very dense and very heavy. If you go one step further, let's say so far the electron would prevent further contraction. Electron moving around the center. Imagine if I increase its force. So I'm going to force this electron to go to the center of the nucleus, which is proton. And they're going to combine together and turn into neutron. So neutron star is one step deeper. When the planet is heavier, the push is more, and then this electron degeneracy, which prevented from further contraction, is not able to live with it, so everything contracts, and everything turns suddenly into a ball of neutron. And that is amazing, because if you bring 1 teaspoonful on the planet Earth, it weighs the weight of the entire Himalayan mountain. That heavy, because so dense. What is the size of this corp? The size is the 10 kilometer. You will not be able to see with the telescope. All we see is an indirect signature, which I'll show you what it is. This is called neutron star. Neutron star is moving rapidly around its axis because all this motion that was present suddenly turned into a smaller diameter. It's called the preservation of angular momentum. I don't want to bore you with that. But the spin is very rapid. For example, 6 to 1,000 per second. This mass is spinning around its axis. Here is the deal. The supernova has taken place. The center has turned into a neutron star, and this is what we call supernova. And supernova is the one we will see with the telescope. The shell, the outer shell. So what is supernova? Supernova is when the fusion of a star stops, has to stop. You know, no more hydrogen burning, no more helium burning, no more carbon burning. Everything is burned up until we reach to the iron. Iron is the last. Iron would never, ever change to anything else because the cost would be too much. You can't fuse the iron together because it costs a lot of energy, and you cannot break the iron because it costs energy. So once you reach the iron core, that's stable, and that's where supernova will take place. Suddenly this force of gravity comes in because there's no fuel to hold this shell outside. So suddenly it forces in. As they force in, as you bang a ball to this surface, would jump up. The whole shell would just go away, and that is called supernova. The supernova is extremely, extremely violent situation, and the brilliance of light is almost 100 billion sun. Is more brilliant than the entire galaxy for at least 2-3 weeks. That brightness, if it happens. The Chinese recorded this. I'm going to go a bit faster because the time is short. So the supernova, this is beautiful. The Chinese recorded in their book on the 4th of July in 1054 that a guest star has appeared in the sky. They didn't know what it was. Only called a guest star. It lasted about 2-3 weeks, then gone. But now we found what it is. It was a supernova explosion then. Why we know what that was? Because what they recorded in that constellation was exactly what we found the signature of this. It was a supernova. It's called Crab Nebula, which we can see it with the binocular if you have. And it was a remnant of that tragedy, which is so interesting, so interesting. So this is the one. This Crab Nebula, this is the explosion that happened in 1054, 4th of July. The Chinese recorded this. Why we say that's it? Because we know this. We know how far this is moving. From that speed, we can then figure out what was this distance traveled, how long ago. When you calculate, you come exactly a year of 1,000. Give and take 50 years, that's what it was. So what about black hole? Now, the neutron stars still are going to stop the gravity from pushing them because they have their own force. Now, if I push a bit more, then everything goes to kaput. This neutron star will then cannot anymore take it. They turn into black hole. Black hole means the rupture in the universe. We don't know what's going on, but we know there's a hole here. This black hole is the result of massive star dying and the neutron are not able to prevent further contraction, further. This is the ultimate victory of the gravitational force. The only thing we know, there is a radius around it, they call that event horizon. If you go beyond that, you will go on. The event horizon, the time stops. If I have my watch on me, my time stops right there. It's not going to move. This is the curvature of space-time. Time stops. If you go a bit further, you turn into a spaghetti and go in. So don't try to get close to it. So the black hole, I told you about black hole at the center of a galaxy. Have you guys seen that the 2019 images that came out from Harvard and from a group all around the world? They showed that beautiful circle of black hole. I'm sure you've seen the paper, didn't you? That was a black hole at the center of Virgo, which has 5 billion mass of sun. That picture came from there. So how elements are formed, this is also another thing that shocked me the most. The Big Bang only gave you hydrogen and helium. So where the rest came? The rest came from this fuel, the fusion that takes place inside the stars. So every element on the periodic table is created up to iron, not more than that, inside the stars. So what about the rest of them? The rest of them are born when the supernova, which has horrendous energy, takes place. So the neutron will attack this nuclei and make heavier element. Like this supernova that happened from the collision of 2 neutron stars in 2017, when it was recorded by the LIGO. That a lot of gold and a lot of platinum was created then with this collision. But a star only can make up until iron. The rest is made outside of its stars in the supernova or collision of neutron stars. And here is the shell business. The very center is iron. Then as you go, you see other elements. You can see silicium. You can see then after neon, oxygen, carbon, helium. Keeps going on till the very last piece, which is helium. So, or hydrogen. So the elements are made inside the biggest star from the fusion. So here is, I like this one. I'm sure you have seen this. This happened in February. Usually comes around November in the northern hemisphere. This is called Orion. This is the constellation Orion. In this constellation, 2 stars are very bright. One is very blue, one is very red. This one has a low surface temperature like 3,000. This one has a surface temperature about 30,000 degrees. This is called Rigel, and this is called Betelgeuse. The Betelgeuse has come to the end of life. We know that the core of this is iron, and any minute it can explode to supernova. And if that happens, we will see it on the planet Earth. But unfortunately, because they're about 600 light away from us, light year, we will not see it. 600 years from now, the people will see it. Only we see it if it happened 600 years ago, which we don't know yet, right? Suddenly, morning you wake up and see, oh, suddenly the sky is bright. In the morning, there's another sun next to the other sun. That is the supernova from this Betelgeuse. And then the last one is this one sent by Cassini. Cassini, which was sent to explore the planetary system, mainly Saturn and its moon, finally was ordered to kill itself by descending into the atmosphere of Saturn. And he sent this picture from the Saturn. And here this dot is the planet Earth. I just want to show this to see how small we are. How small this planet is and how stupid we humans are, which we think we are sometimes, we think we are God and become so arrogant, so selfish. So this, my advice to you is, if anything astronomy taught me, it made me more humble. Let's say I'm nothing. I'm done with the speech. So thank you very much for listening to me. I'm sorry it was a bit long, but if you have any question, I'll be glad to answer. Otherwise, we'll just quit. Sir.
Interesting. You said I'm not a man of religion, so
I'm not.
and all this is happening. How do you put it all together? Do you think we have an existence on this earth which is ephemeral, and once we're gone, or you think we're part of a bigger picture?
That's a good question, by the way. I'm saying this my personal opinion.
Sure.
My personal opinion is that we were dust, we will turn into dust. I don't believe in afterlife. I don't believe that I think you're good. If you're going to be a heavenly person, do good to the people here. Serve them. If there's a heaven, you will go to heaven. What can I say? But personally, as a scientist, I don't believe that there is such a thing, because we see it every day, what's going on. I mean, there's a finite life to any element in this universe of us. We are not here forever. And if we believe that we human are special, remember we said Earth is the center of the everything? What happened? Not only we are not in the center, we are not even in the center of galaxy, Milky Way galaxy. We are 27,000 lights away from it. So, and then what is the Milky Way? It's nothing. It's a very small galaxy compared to our neighbor, Andromeda. It's twice or 3 times as big than us. And I told you about the center of Virgo. Virgo, the black hole at the center of Virgo is 5 billion stars. The weight of that, 5 billion sun. So when you think of this, we are not special. I can tell you this. That's my personal. We're not. I think we are very much like the rest. And you want to enjoy the life. Enjoy the life. Be good to other people. Be good to yourself. And don't be stupid. Don't be arrogant. Yes.
Is there any explanation for the fact that the galaxies are still not only moving away from each other, but accelerating?
This is what they call that dark energy. Nobody has been able to explain this, but we have a proof that this is happening. I mean, this is the observation. And this observation, 3 scientists, one from San Francisco, and a couple of them, I think, from, I don't know exactly, probably, but from West Coast too. They won the Nobel Prize for the discovery. I mean, they don't give a Nobel Prize for something which is not proven experimentally. They showed, based on the supernova explosion, that the distant galaxies are getting farther away, because we have now the fingerprint of these galaxies. We have a way to find out what's going on, because we can simultaneously with the computer, with the supercomputer, we can register every night billion galaxies simultaneously, and we can see which one supernova takes place. Supernova is not something that happens every night. On planet Earth, the last time it happened was when Thorsten Brahe was alive. It was 1575. He recorded that as a nova. It's not common. The recent one in '87 happened in a big Magellanic Cloud in the southern hemisphere, which is about 150,000 light years away from us. It is not that we see it every day, but this group in California, they came up with this program with the computer. They don't have to look. All they have to do is zoom this telescope and let the computer do the job. And they recorded every night an explosion taking place in different places in this universe. And they figured out where it's coming from, and they figured out the distance. The computer can measure for you the distances. And we see that proven. They're running away. Running away. The universe is not stable. Yes, sir.
On the question about the origin of life and all, what will happen should perseverance on Mars determine that there was, in fact, at some point, life on Mars, or that there was life, or is life, in the waters of some of the moons of Jupiter,
right.
or that there are signatures of possible life even in the atmosphere of Venus. It makes me think that the universe is life.
In other words, they're all life. Life may not be this form everywhere, because now we have found out that there are 100 billion planet-like planet Earth in this Milky Way alone. So can we say there is no life? But the distances are so massive, it's hard to communicate. It's hard to communicate, right? We will never be able to escape the solar system. The best we can do is get to Titan. That's the end. I mean, you should not always predict like this, because many people who predicted in the past proved to be wrong. But with the technology, I mean, energy, massive energy it takes. The only hope is if we find a way to use the antimatter. If we find a way to use antimatter, which is very expensive to produce, antimatter completely turns to energy. Maybe then we can come up with a satellite, with the spaceship that uses this kind of fuel, then we can go in inner space to explore other areas. Doesn't happen. Too bad. I think we are locked in this place, but don't doubt for a second. I don't doubt. My second, there is life. As I said, it may not be this like DNA we have. Maybe based on sulfur, maybe based on nitrogen. It doesn't have to be carbon-based like human life is on this planet. It's based on carbon. Carbon burns and turns energy. Maybe there are other elements. We may not need to have oxygen. We need something else. Water is essential, though. Without water, I think everybody agrees the life is not going to develop because the radiation kills you. The reason we survived because the radiation before we have atmosphere, this radiation coming from sun, X-rays, would kill any living creatures. So the reason we can say this now because you have atmosphere of ozone layer, so it prevents the ultraviolet light to get here. But at the beginning of this planet, if there was any life, it would be destroyed immediately. So it has to be water. So they go deep in the water and develop. Thank you. You're welcome. Thank you. I hope I didn't bother you guys too much with talking.